prove by mathematical induction that if you take the sum of the first n integers, you get n times n plus 1 over 2. So if you're going to prove something by mathematical induction, you need the starting case, which in this case is n equal 1. And if this statement is true for n equal 1, that says that 1 is equal to 1 times 1 plus 1 over 2, which is 2 over 2, which is 1. So this formula, I'll give it a star, this is true for n equal 1. Okay? And then how do you prove something by mathematical induction? You say, okay, assume it's true for some number n, prove it for n plus 1. So let's say we assume that this statement star is true for n. Must prove it for n plus 1. So what does that mean? It means we have to look at the sum 1 plus 2 plus 3, not just up to n, but to n plus 1. And what is that? Well, we can think of that as the sum up to n, and then add n plus 1 to that. And because we're assuming that star is true for n, this is equal to n times n plus 1 over 2, that's what this is, plus n plus 1. Let's look at that for a minute. I can factor out an n plus 1, and I get n over 2 plus 1. Now, in algebra, you certainly have to know high school algebra. Let's see, this n over 2 plus 1 is the same as n plus 2 over 2, right? n over 2 plus 1 is n plus 2 over 2. So I can write that as something over n. And what over n? n plus 1 times n plus 2, which is n plus 1 plus 1. And that is exactly this formula if I replace n by n plus 1. So therefore, the statement is true for n plus 1. And that means we're done. In mathematical induction, you prove something is true for 1, and then you prove that if it's true for n, it's true for n plus 1. So if it's true for 1, it's true for 2. If it's true for 2, it's true for 3. If it's true for 3, it's true for 4, and so on and so on and so on forever. And so we have proven the theorem. So the sum of the first n positive integers has this very concise expression, n times n plus 1 over 2, and that's true for all n. So this is a nice example of a proof by mathematical induction.
Professor, can you move the page up? We cannot see the bottom, the last line.
Oh,
Thank
it just
you.
says that we win and it's true for n plus 1.
Oh, thank you.
I have a question. How do we get the n on the denominator? Shouldn't it be 2 on the
Oh,
denominator?
that was just a mistake. That's 2. Thank you. So that's 2 is the denominator. Thank you. I'm going to record, as I am now, all of the problem sessions as well. So I'll have a separate playlist on YouTube for the recordings of the problem sessions.
And also, you said that the lecture, today's lecture, is gonna be up when?
So as soon as I close down this session that we're in right now, I will upload the first lecture on mathematical induction to YouTube. But for some reason, either because of the capacity of my internet connection or just because these video files are so big, it can take a very long time for a video to be uploaded to YouTube. So that first video should be up in an hour or so. I can't imagine it would take longer. And there'll be additional videos that I upload later this evening.
Okay, because I'm just trying to get this homework done like now. So my question, some of the questions are asking me to use proof by mathematical induction. So it's pretty much the same thing, right? If you just have to
Well, the
prove that
method is the same.
okay.
It's just a matter of being able to set the problem up properly to understand what the strategy is for doing something by induction. And then there's always a little bit of algebra, more or less complicated. Here we had a little bit of algebra we had to do. And when you look at the formula for the sum of squares or the sum of cubes, the algebra is not really hard, but it's just a little bit more technical because we're dealing with squares and cubes. But the idea, the method is exactly the same.
Okay. Another question. Will we be going over this homework?
I'm
Or no?
sorry, I didn't hear you.
Sorry, I was asking what are we going to be going over the homework? Like after we submit, are we going to be?
So that is the nature of the problem sessions. I show up, you show up, you ask me a question. For example, can you go over the homework? And I will go over the homework. Okay. So the problem sessions are really for me to answer your questions. And your question can be, can you go over the homework? Or can you go over, these 3 problems from the homework? And I'm happy to do that.
Okay, thank you.
If there are no questions, I might just do a couple of homework problems for fun. But the sessions are really to give you the opportunity to ask me stuff. Okay. Anything else? If not, I will get back to trying to upload some videos to YouTube. And I hope I will see and hear from you all tomorrow. Any questions before we log off, before I log you off?
Yes, Professor.
Yeah, Professor, I
Oh,
have a question about the midterm and the final. The midterm and the final will be time out? Like you're gonna send off the midterm and the final, and you're gonna say like in 1 hour and a half, you have to finish the midterm.
Right,
the
so
final.
basically it'll be this.
You're gonna have the full day.
For the midterm and the final, I'll say the exam is, let's say, at 3 o'clock. At 3 o'clock, I will post the exam on Blackboard and email it to you as well. And you have until 6. I mean, it's supposed to be roughly an hour and a half or 2 hour exam. Because of all the technical complications with the internet, I'll give you, let's say, 3 hours. So you have an hour to make sure you can scan the pages and upload it. And that's the way it works. For the midterm and the final, there's a fixed exam time.
Okay, thank you.
Professor, my question was about the nature of the problem sessions. How long do you expect to stay on the problem session? Does it all depend on how many people are there and how many questions you have, pretty much? So,
Yeah, but I have consecutive problem sessions for my calculus. So at most an hour. That's the answer.
okay.
So the session from 4 o'clock at 4 o'clock will go, it can go up to 5 o'clock. But if at some point everyone has run out of questions and there's nothing to do, I'll say goodnight and goodbye and go drink my coffee. And it's the same with the
Okay.
morning session. I've blocked out an hour from 11 to 12 in the morning. And just as I blocked out this hour from 4 to 5 in the afternoon.
Okay. Oh, and Professor, I also sent you an email about an obligation I have Thursday the 23rd, just to give you a heads up.
That's right. I don't take attendance at these sessions. For one thing, I don't even know how to take attendance over the internet. It's not really possible. But you don't get graded for showing up. You get graded for learning algebra and doing the homework and doing well on the exams. So
Right, right. I just sent the email because we have the midterm that day. That's why.
Oh, that's more of a problem. Yes. Yeah, if any of you is going to have a serious difficulty with the time for either the midterm or the final, let me know. And yeah, let me know.
Hopefully, I can work my way around it, but I just want to let you know today. That's
Okay.
Professor, for number 5.
Sorry?
Question 5, example 5 in 1-1. In the first the first whatever pack of sets, the first set of exercises, it talks about the combinations, I guess. Combinations C, comma, N, comma, K.
Mm-hmm.
So is your going to address that, because I read the text and it doesn't really, I guess it's supposed to be a review. Maybe they expect me to know that, but I don't know. Like what I'm saying is,
just,
text doesn't help me answer it.
so I think, so the number of combinations, these are what are called the binomial coefficients. And so what does problem 5 say?
It says, here we go. It says, let n and k be non-negative integers, and let C of n comma k denote the number of subsets in cardinality k contained in a set of cardinality n. So it's pretty much A through F of a bunch of proofs of, C of n comma k.
Right. So that is, cardinality just means size. So to say that a set has cardinality 6 means it contains exactly 6 elements. And if you pick a number like 3, you ask the question, how many subsets, how many ways are there to choose 3 elements out of a set of size 6? And that is this number C of nk, which is also written often as the binomial coefficient. And it should be possible to do those problems just from that definition. But the best thing is to think about it overnight. And if you're available at the 11 o'clock session tomorrow and you're stuck, ask me and I'll explain a little bit more.
That's fine. I mean, I know for the binomial expansion, you have to do like a combination, right? But the issue is that when it says to prove it, because I know how to do a combination, I can put it in my calculator. But how do you prove
Exactly.
it?
So in this class, as in any upper level math class, half of what you're expected to do is to prove things. So one of the things you're supposed to learn in an algebra class, abstract algebra class or modern algebra, is how to give a mathematical proof. Yeah. So it's not just a matter of calculating, it's a matter of giving a very precise mathematical argument, a proof that something is true. And one of the things you're supposed to learn in algebra is how to give a proof. That's important.
Okay, so I'll look at the lecture that you post, and then if I have a question, I'll ask tomorrow.
Yeah, that'd be great. That's good.
No worries.
Anything else? Okay. So let's just say 1, 2, 3, going, gone. See you, hear you all tomorrow, I hope. Right? Everybody take care.
Thank you. Thank you.
Thank you.
Thank you.